Okay guys, so I have been asked to explain to you how to figure out your rafters using the longhand method. In other words, I'm not going to be using the construction calculator, but instead I'm going to be using the regular calculator. And so using the regular calculator, you need to make sure that your calculator has squared and square root on it. So for this example, I'm going to use this little barn here, and the main roof is an 8 and 12, and the shed roofs to the side are 2.5 and 12. So I've redrawn this a little bit to kind of show you how the rafters are going to look in here, and I just realized that I had forgot the ridge beam, so let me draw that right in there right quick. And remember that your ridge beam must be a size bigger than your rafters, and in this case my rafters are 2x12s. So I'm going to draw this in as a 16-inch LVL, and you'll see that it is going to be a little bit longer than the rafters. I'm going to go ahead and trim this out so that it looks, I'm going to leave that point there, and actually I'm going to draw a center line in here to show you what the center line is, and or where the center line is, and you can see that there's the center of that particular roof. There we go. All right, so a couple of things that we need to know is we need to know the span, and the span can be found from the plan, the floor plan. So the span in this case is 20 feet. So hopefully I've drawn this out correctly, and I'm going to have 20 feet. There we go. So good deal. I've done something right today. Today it seemed like a Monday. So this is our span. And we need to know our run as well. So we know that our run is equal to half the span. Run equal to the span divided by 2. All right, so we're just going to pop us in another dimension line there, and we have our span as 10 feet. Our run as 10 feet. So run. All right, so these are generally what is given to us on the plan. We know our span, we can establish our run, we have our rise over run in our unit triangle. So I'm gonna call this the unit run, or unit R. And I'm going to call this the unit rise, or URI. Now we can establish that. Now this through here is called the unit diagonal. So let me go ahead and put that in there. Unit diagonal, which we're going to call UD. Okay, so how do we establish our unit diagonal? So if you'll remember, I said that we could go in here and, of course, let's see, which one was it? Not that one. I've got way too many open here. Let me just do it this way. So there, that's the one I was wanting. So a couple of weeks ago, I told you that we could look on here, and so these numbers across our framing square end up being the, can't draw, it's the rise, the unit rise. So these numbers here equal the unit rise. All right. So in our case, we're talking about 8. So if we look right up under it, the length of common rafters per foot of run is 1442. So what's that saying is that if we look on there, we're going to end up with a UD is equal to 14.42. All right, so this number here is a very broad number. In other words, we can improve on this number very, very greatly to end up with better, more accurate measurements here, and we'll see how that works out. We'll do them both. So to figure out what this actually is, let's go over to our regular calculator, and we're going to say 8 squared plus 12 squared equals, and then we're going to hit the square root to end up with a huge number. Now you'll see that it's, we were looking over there a minute ago and it was just round off to 2 decimal points. But now we see that this number is huge, 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 huge. So I'm going to copy that, and I'm just going to add to this. So it is actually equal to this big long number here. All right, so we'll see if these two numbers work out differently. Now keep in mind that if we're looking on this over here, and some of these, like this one here is 1389, 15, or let's see, wait a minute, 16,228. So if these numbers were really long, maybe these numbers might work out a little bit different, and it might change the length of our total diagonal by a lot here. And it could, by an inch. All right, so if we look at, we've got that small triangle here, and let me just draw that out so that you understand what I'm saying, the big triangle and the small triangle. So this is the unit triangle, and then we have the big triangle. And so I want to explain that, and I think I've explained it before, since we have this bird's mouth and it goes up into the rafter a little bit, then this is not, this triangle has to go from this point here. So this larger triangle is going to go from the bird's mouth and to this point. All right, so you can see that this smaller triangle is equal to the larger triangle as far as a unit is concerned. So when we say that it's an 8 and 12, well, this is equal to the same thing, except it's just bigger. So let me explain that. So if I were to say, actually I'm going to do this in a little different form here where I can do a little bit of freehand drawing. All right, so if I say that 8 over 12, or 8 over 12 is equal to y over 10, that's basically the same as saying that UR over, I'm sorry, wrong, URI, or the unit rise, over the unit run is equal to the total rise, which the total rise is here, over the total run, which is here. So these two are equal in a fashion of scale. How am I trying to say this? What am I trying to say? They are proportionally equal. Let's say it that way. They're proportionally equal. So if I use my regular calculator here and I say that 8 divided by 12 equals this crazy number here, all right, so 0.667, I'm just going to roll it down, is a multiplier is equal to y over 10, or excuse me, 10, say one thing and do another, then I want a figure for y, so y is equal to 8 over 12 times 10, or it is 0.667 times 10, which is, whoops, wrong button here, which is, of course, 6.66667. All right, so this is equal to 6.667. All right, and we know that we can that 0.6667 is 8 inches. So this is 6 foot 8 inches. I'm just crazy. I'm scatterbrained this morning for some reason. So let's figure out if that's right or not. All right. So we have our run, and so if I'm correct, then if I measure from this point to this point, I should have 6'8", and I do. All right, just like what we figured out here, I have 6'8", and that's what that actually worked out to be. Now we need to find out what our total diagonal in here is. Let me just go ahead and put, this is the run. There, run. Okay, so now I need to find out what my diagonal is, my total diagonal is here. And let's go back over here, and I'm going to clear some of this up real quick. To there. Anyway, it's going to stop at that point. I can erase the rest. And we said that our run was 6'8". I shouldn't write it that way. Let's write it this way. 6'8". And that is our rise. And that's from this point to that point. Now we're trying to figure out what our total diagonal is. Now, using this god-awful number here, I can figure out what this is going to be. All right, so pull up my construction calculator, and just so that I get everything correct, I'm going to go back through this, and I'm going to put this big long number in here. I should have saved it. So 8 squared plus 12 squared equals, and I hit my square root, and I got that crazy number now. Now, that number, this number here, is that. All right, so if this is equal to a foot at this point, if I take this number and I multiply it by the number of feet in run, which so happens to be 10, I should equal out to times 10 equals a huge, huge number. Now, wait a daggum minute here. So, what's up with this number? 144.22, and it goes on out. All right. Well, because this is inches, all right, because this was inches and that was inches, this gave me inches. So this converts. We didn't put a factor in here, whether it was feet and inches or whatever. So this comes out to inches here. So to figure out what these actually are, I'm going to divide that by 12, and that gives me 12. feet. All right, I'm going to subtract that 12, and then I'm going to multiply that times 12 again to give me 0.22222. All right, so there's 0 inches. All right, so I can take this number here and I can multiply it by 16 to find out that it's going to be 3.55 or 4/16, which is 1/4. All right, so now I know that it is 12 feet, 0 and 1/4 in here. So if we've done this right, let's go back over to CAD. If we've done this right, I should have the right number here. All right, so I'm going to go to the top of the triangle, to this foot of the triangle, and look at there. I did have it right at 12 foot 0 and 1/4. Now, that is what we call the line length. And I know some of you guys have asked me, what in the heck are you talking about line length? I didn't spell that right, did I? I'll tell you what, I wished I could spell. There, much better. All right, this is called the line length. Even though it is a diagonal, it is the line length from the center of our roof to the bird's mouth. So if we were trying to cut this out, when we go to do this, and let me just copy this and this and that, and this over here, and I'm going to pull this up. Nope, I don't want to move it. I want to copy it, stupid. Copy. All right, so I need to cut this out of one single piece of wood. So when I do that, I technically actually do it in this fashion. So I've laid this piece of wood out like that. And I have measured down, and let me just do this real quick, kind of explain to you what I'm doing here. So I'm moving this up, and when I take this piece of wood, and let's just do this. I'm going to pretend like this is a whole piece of wood here. Bam. All right, so I don't technically have anything but just marks on there, on this piece of wood. All right, so if I measure down 12 foot 0 and 1/4 inch, and then I project on that same angle downward, you'll see that it lines up. Well, it's a little bit off, so I must have done something weird, but you can see that that lines up with that bird's mouth. Okay, so basically I just pulled down here that 12 foot 0 and 1/4, and then using the same 8 and 12, this is an 8 and 12 here because I'm using the framing square to project this down, then I have my bird's mouth. Now my bird's mouth is basically just 3.5 inches. Generally, we just do that bird's mouth at 3.5 inches, and you can see how that works out there because that is the width of a 2x4. All right, so we've got to the point where we figured out our bird's mouth, and we need to come back up here and we need to take off 3/4 of an inch here. All right, so we're going to cut this board at this point, even though this is the center line of our roof. And please let me know if I have just absolutely, completely, totally confused you guys. All right, so that was the center line of our roof and then we came off of that 3/4 of an inch because the width of our ridge board, okay, half the width of our ridge board, and we have our bird's mouth. So the actual length of this, how would we figure that out? So let's go back over to here. And let me clear some of this out. We have to modify our run to get the actual length from here to our bird's mouth. But I'm going to do a couple of things to get the actual length of the whole thing. So I need to know how long is the real deal here. Not the line length, not the theoretical line length, but how big is, this whole thing. So again, I've got to do some things here. Number one, I've got to figure out what my overhang is. And I need to subtract this 3/4 inch at the top for my ridge board. So first of all, we got to find out what is the overhang here. I'm not sure that I got to the point where I was actually putting that in, which I didn't. So I'm just going to measure what I've drawn here, and I think it's 1'8". No, I don't want to do it. Yeah, I do. 1 foot. Let's see what that is. Oh, it is. So I was right. It is 1'8". Most of the time that is pretty much standard for the houses that I draw. All right, so let's go back over here. I've established that. Technically, if I were really, doing the right job, then I could go to the roof framing plan and I could look on here, and this particular one is 1'6". Let's see if I have another one. I might have drawn the darn thing wrong. I don't know. It's not on there. I got a roof. I don't have a roof on any of those. I know I haven't got to that one yet. So, actually, I do believe I have drawn that other one wrong. Doggone it, I hate when I find this out in the middle of a class. So this is not 1'8", it's 18 inches. So this, I'm going to move 2 inches, and there. So now this actually should be 1'6". It is, yeah. And I'm sorry, I get my 18 inches and my 1'8" kind of mixed up from time to time, but it should be 1'6". Okay, so with that, I'm going to just start me a new one since I've got all of that on there. All right, so I need to take off for 3/4 of an inch here, and I need to add the overhang to my run. So my modified run is going to be equal to the run, which is 10 feet, and I'm going to subtract 0 feet, 0 and 3/4 of an inch, and I'm going to add 1 foot 6 inches. All right, so using our regular calculator here, we have to kind of work a little bit backwards on this. So I'm going to clear this out. And I'm going to say 3 divided by 4, obviously, is 0.75, divided by 12 equals 0.0625. So that's what this is in feet. Okay, so this is feet and inches, and then it's what did I say it was? 0.0625 feet. Okay, so that's that. So now I can go in here and I can make this a negative, and I can add 10 feet to that to end up with 9.375. And then I'm going to add this 1 foot 6 inches. So remember that 1 foot 6 inches is 6 divided by 12, which is going to be 1.5 feet. All right, because 6 divided by 12 is 0.5. So plus 1.5 feet equals 11.4375. 11.4375 feet. All right, so this is now my modified run. Okay, so I'm going from, actually, come back. I'm going 3/4 of an inch off, okay, from center, and then I'm going all the way to the outside here. So that is equal to that. All right, so let's go over to CAD and see if we were correct on that. So I'm going to go measure from here to the outside here, and that is 11 feet 5 1/4 inches. Is that correct? So let's go back over here and check this. All right, so this is what we're going for. How do we figure this out? Number one, we need to subtract our 11. Actually, I'm going to go here first. That one, yes. All right, so I've got 11 feet. So I need to subtract that 11. And then that leaves me with just this 0.375. I'm going to multiply that times 12 because there's 12 inches per foot. And that gives me 5 inches. Subtract the 5, multiply that times 16, which is the smallest increment that we use, and that's going to give me 4/16. 4/16 is equal to 1 1/4 inches. 4 over 16, if I work that down to the lowest common denominator, that is 1. Doggone it, I'm just going so good today. 1/4. So back over here, was I correct? Yes, I was. All right, so that is exactly 11 foot 5 1/4 of an inch, and that's my modified run. Now, with a modified run, going through exactly the same things that we were doing up here with this long number, then we're going to find out what our total length here is, and that should be from this point, not the center line, to this point. Okay, so that should be from there to there if we do it correctly. So let's go back over here and see if we can run that correctly. Actually, I'm going to kill that and kill that, and I'm going to start a new one because I've got my modified run on there. There. Okay, so I got to put this long number in here again. All right, so I'm going to go back and I'm going to do it again. I didn't save it, and I'm going to have to clear this all out. 8 squared plus 12 squared equals square root. This time I'm going to save the dadgum thing. There, now it's in memory. I don't have to go back and do it again. All right, so now I got to put in this long number here. All right, so how do I put this number in? I should have saved the other number, shouldn't I? So 0.25, actually I can just do this all at one time because I know that 1/4 is 0.25. 5.25 divided by 12 remember that number? Plus 11 equals back to that original number that we had. Times memory recall, which is that long number, equals, well, here we go again with that long number again. So that long number is the modified diagonal. Okay, so this is our rafter length is equal to 164.95, and I'm just going to leave it at that point. It goes on out there a little bit unless it keeps going. But this is the number. So now I'm going to save this. I'm going to save this number. So memory clear, memory plus. Now I've got this number, and I need to convert it over to feet and inches. So because this was in inches, so that when we multiplied it by this, we ended up with inches. I've got to convert that over to feet. So I'm going to multiply that times 12, and that gives, I'm going to divide that by 12. All right, so that gives me 13 feet. 13 feet. Going to subtract the 13. Now I'm going to multiply by 12 to end up with 8. All right, so I'm going to subtract my 8, and then I'm going to multiply that times 16, and that gives me 15/16. All right, so that is going to be from there to there. So let's go back over to CAD and see if we've done it correctly. So I'm going to do a aligned, and I'm going from the corner there, which I don't want to have that ridge board on there, and now I'm going to the overhang there, and I have 13.9. Now let's look at that number. 13, 8, and 15/16. What's that thing done? Watch this. So I'm going to go in here, and I'm going to go to precision, and I'm going to go to 16ths. Look at there. Bam! 13, 8, and 15/16. I love it when a plan comes together. So this is my rafter length. All right, so, and I'm going to explain to you a little bit more what I'm talking about. Rafter length. I don't know why this thing runs backwards like that. Oh, because it's figured up for center. Okay, so that's my rafter length. But if you'll notice, I've got a little point back here that's not exactly right. So if I needed to find a board, I can't use 13 feet, 8, and 15/16. Obviously, I'm going to have to use an 16-foot long board to cut this out of. So, when you go to figure this here, how would you figure that? Well, you got to figure for this length here. I'm not going to get into that because it's a huge issue, and I don't want to do that at this point. Now, we have figured out what our length is for this, but what about this? This works exactly the same way what we were doing before, except now we're using 2.5 in 12. So I need to find out what my unit diagonal here is. So I need to find out what UD is. All right, so that's my unit diagonal. And so my unit diagonal, UD is equal to 2.5 squared plus 12 squared, and I need to put that in parentheses, and that's going to be the square root of that. All right, so to figure out what this is, I'm going to go back over here, and I don't need that number now yet. I don't need that number now. I'm going to clear everything out. And I'm going to say 2.5 squared plus 12 squared equals the square root of that, 12.2517, yeah, blah, 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 blah. All right, so this is a long, long number here, and I'm just going to do this, which is equal to that big long number there. So if I were to measure this here, I end up with that number. Now let's see how closely. You can obviously already see that 12.25 is in there, even though this is rounded off. Let's go to let's figure for our precision on here a little bit more. We'll go down to a 16th, and it didn't change. That's interesting. Let's go down to 64th, and it still didn't change. So obviously this 7650, so forth down through there, is not going to affect the ultimate end excuse me, on that. So let's go back and check that just to be sure. So I'm going to subtract the 12, and I'm going to multiply this number by 16, and I end up with 4/16, which is 1/4. Look at that. So these numbers did not affect the end result on my unit diagonal there. So that's good. That's good. So with this number, I can start going through that whole rigmarole that I did to figure out what my, to find out what my line length is. Remember that the line length is to the bird's mouth. So if I'm got a little triangle here, it's going from the outside edge of my bird's mouth to the center of the roof here. So let's make that a center line. I'm going to have to make this smaller, so there we go. A center line, and then I got to kind of play a game here to get this to that point there. So that is our triangle. Okay, so we've got our unit triangle, we've got our total triangle. So if we go back to our plan again and look, and we have a run of 12 foot, so our span, since this is a shed roof, then our span and run is going to be the same. Whoops. Obviously, I didn't draw it right again. Ain't that something? Doggone it. What the heck is wrong with me? All right, so I'll fix this right quick by jingoes. $12 foot. So the old saying goes, do as I say, done as I do. Yeah, always check your work to make sure that everything is kosher the way it's supposed to be. There. Now, that's the way it should be, because that's what the plan said. Okay, so I need to find out what my run is going to be. Now remember, my run goes to this point. It doesn't go to this point because we don't know what this measurement here is. So to find out what our unit run is, we're going to say unit run is equal to the, oops, sorry, wait a minute. Let's try this again. There. My unit rise, unit rise is going to be equal to, why can't I get this right today? Is going to be equal to the unit still can't get this right, total rise is equal to the unit rise divided by the unit run times the run. All right. So again, remember that on a shed roof, the span is equal to the run. It's all the same. All right, so we need to figure out this using our construction calculator or our regular calculator. We're going to say 2.25 divided by 12 is equal to y over 12. All right, so we're going to work for y is equal to 2.5 divided by 12 times 12. All right, so what's that going to give us? We can do this, without even using a calculator. It's going to give us 2.5 because these two cancel out. So this rise here is going to be 2.5 feet or 2 feet 6 inches. You want to check it out and see if we're right. So remember again, it goes to there, to here, and look at that number. Okay, since this number and that number are both 12, even though this is inches and that's feet, this would convert to feet as well and give us 2 foot 6. So that is our rise. All right, so the only thing left is we need to figure out what our line length is. So our line length is equal to the unit diagonal times the run. Okay, I'm going to go ahead and just clear out both of these and start a new one each time. That way I don't have to go back and erase everything. All right, so in this case, our unit diagonal is this big long number here, 12.257650, blah, 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 times our run of 12 feet. Now remember, this is going to come out in inches because this is inches. We don't actually put that feet in there, so I'm going to go ahead. This just turns out to a unit. So let's see what we get here. Oop, wrong calculator. And I didn't save that dang number again. Doggone it. All right, so cleared out. And 2.5 squared plus 12 squared equals square root. We ended up with the wrong number there. Let's try it again. 2.5 squared plus 12. I see what I'm doing now. 2.5 squared plus 12 squared equals square root, which is that number. Thank God I got it right. Times 12 equals this big long number here. So 147.00918. All right, so now we need to convert this over to feet and inches. It's in inches now. All right, so I'm going to, am I going to save this? I might as well save it. All right, so I'm going to divide this by 12, and I end up with 12 feet. Subtract the 12, and multiply it by 12 feet per inch. And I end up with 3 inches. Subtract the 3 and multiply that times 16. End up 1/16. All right, so our line, this was our line length. In other words, it's from here to the bird's mouth. That's our line length. Go back over to CAD and see if we got it right. So I'm going to measure from here to there. 3 1/8. And if I go and do this precision thing again, there. And that is what we have. 12 feet, 3 1/16. Now you may ask, why am I going and checking this precision thing? Why? Because I have the precision currently set up to 1/4 of an inch. When we go to build houses, and I'm looking at a plan here, if I've got like 8 foot 0 1/16, I mean, geez, the draftsman obviously didn't do his job very good because he's trying to simplify this. As a matter of fact, I don't even use 1/4. If my windows and doors don't work out to 1/2 or better, then I move them. So you're not going to see any of mine. As a matter of fact, come over here to the house. Let's see. Actually, let's go to one that I've already done all of the numbers to. So this is, okay, so this is the foundation plan for the homeowner. This is the foundation plan for the builder. You will see, and you know, when we're looking in here, everything is no smaller than 1/2 inch. And if it don't work out, I move them. Because the builder doesn't need to be building to 1/16 of an inch. He needs to have everything simplified for him. And that is the job of the draftsman, to go through and make sure that everything is coming out the way it should. Okay. All right. Let's go back to here. We're not done yet. So in this case, there is actually going to be a nailer here. And this nailer is going to be the total of 1.5 inches. So this piece of wood here is going to be nailed up on the side of this wall here. All right. So there's going to be a nailer on here. And it's going to be equal to 1.5 inches. So whereas over here we were splitting our ridge board in half and using 3/4 of an inch, over on the shed roof, we're going to be subtracting a whole 1.5 inches off of that. So let's find out if I got this overhang correct. This overhang should be 1 foot 6 inches. Hold your breath. Oh my God, it's not. Okay, so let's move this. I got to go back and fix this plan when I'm done. Come on, dang it. And this was the preliminary plan, just so you know, and so that, you know, this is what the homeowner sees, and things did change. So when it goes to the builder, I have to go back and make sure that all of this is correct, and I will. So, all right, so we have an overhang of 1/6. So to get our modified run, we're going to take our run, which is 12 feet, and we're going to subtract a total 1.5 inches here. And then, put that in the right place. And then we're going to add our overhang here of 1 foot 6 inches. Okay, so open up our calculator here. We're going to start with our smallest number, and I want you to, well, I won't say it right now, but let's look at this. So 1.5 divided by 12. See that number? 0.125. You remember that because that's 1.5 inches. All right, so I'm going to subtract that from 12 feet, and that's going to give me or excuse me, 11.875, and then I'm going to add this 1.5 feet here for my overhang to end up with a modified run of 13.375. 13.375. All right, I'm gonna keep that. All right, so I'm going to subtract 13 feet. I'm going to take that number and I multiply it by 12. That gives me 4. So that is equal to 13 feet 4.5 inches. So let's go back over to CAD and see if that's correct. There we go. 13 foot 4.5 inches. All right, so now we need to find out what our total piece of wood is going to cost, or how long is our total, and that's going to be from this point to this point. So to find out what our total diameter is, our total diameter is going to be our unit diagonal times our modified run. All right, so did I save that? Memory recall? Yes, I did. Good deal. All right, so I'm going to take that. Well, now I got to put in this long number. Oh, going. Okay, so let's go back and put this number in. 2.5 squared plus 12 squared equals square root, which gives us that number, times memory recall equals 163 inches. So that equals 163.94 inches. Now I need to work this out for feet and inches. So I'm going to divide by 12, and that gives me 13 feet. I'm going to subtract the 13 feet, and I'm going to multiply that times 12, and that gives me 7. And then I'm going to subtract the 7, and I'm going to multiply times 16, and that gives me 15/16. So our rafter length is 13 feet 7 and 15/16. Let's go over here and try it out. Remember, I've got to play with my precision here. There we go. 13, 7, and 15/16. Whew. I hope this helps out. Now, these are common rafters, and I'm going to go back and do another video, long-handed, for hip and valley and jacks. So, stay tuned, and we will come back to you. Thanks, guys.